Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or you want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI pipelines, they just launched dedicated CPU instances. In addition to that, they just launched a new data center in Toronto, and they've got one opening in Mumbai at the end of 2019. Go to pythonpodcast.com/linode, that's Linode today, to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of the show. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system that can keep up with you, that's designed by software engineers for software engineers. Clickhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. With such an intuitive tool, it's easy to make sure that everyone in the business is on the same page. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And you can visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And if you have any questions, comments, or suggestions, I'd love to hear them. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host is Tobias Macey, and today I'm interviewing Robert Hodges and Alexander Zaitsev about Clickhouse, an open-source, column-oriented database for fast and scalable OLAP queries. So, Robert, can you start by introducing yourself?
Hi, my name is Robert Hodges, and I'm CEO of Altinity. We do commercial software and support for Clickhouse.
And Alexander, can you introduce yourself?
Yes, my name is Alexander Zaitsev. I'm CTO of Altinity and actually one of co-founders. And we are doing commercial Clickhouse and helping everybody to get most of this excellent database technology.
And going back to you, Robert, do you remember how you first got involved in the area of data management?
I do. It was with a database called M204 back in 1983. This was a pre-relational system that was really popular with the US government and military, and I loved it. I thought it was the coolest piece of software I'd ever used. And since then, I've worked in and around databases through the present time, included working at Sybase, working on clustering and replication for MySQL, plus many others. So actually, Clickhouse, I think, is database number 20 for me.
That's impressive. And Alexander, do you remember how you first got involved in the area of data management?
Yes, I'm certainly not don't have so much experience as Robert. I started to work with databases in the late 90s, so probably 20 years already, and that was various kind of different databases. But since 2007 or 8, I'm mostly working with different analytical technologies. And this is probably the most interesting area, at least for me, in databases. And other years, I worked with a number of cool databases, including Vertica, which is, to the best of my knowledge and to the best of my experiences, the best commercial database for analytics to the moment. But later on, we discovered Clickhouse. Actually, it's 3 years already when Clickhouse is open source. So it's 3 years since it's available in public, and we started to work with Clickhouse very closely, look into that, and eventually migrated huge system from Vertica to Clickhouse. That was a great success for the company I was worked for. But probably I'm going a little bit ahead of the schedule of our talk. But during this exercise, I realized that Clickhouse is a great technology with great potential, but it still lacks a lot of features and support compared to commercial solutions. And that's why I founded Altinity, to fill the gap and to make Clickhouse successful and usable for enterprises.
And so can you dig a bit more now into what Clickhouse itself is? And you mentioned a little bit about how you got involved with it, Alexander, but if you can also share that information, Robert.
Yeah, absolutely. So the way I got involved with it was Alexander has been bugging me for about 3 years about this great database and that I should come look at it. He and I met and have been friends since for about 17. We met in 2002. We've been friends for 17 years and have stayed in contact as we've moved across different companies. And I think the real trigger was that in addition to hearing from Alexander, I was working at VMware for 4 years after selling a previous company to them. And I was working in the business unit that was involved in developing software for VMware partners. And it became clear that Clickhouse just looked like a great fit for a service that these partners could run. And that was really what triggered the thinking about, hey, this looks like something I should sign up for, because this database is runs really fast, is very easy to manage. That looks like a really interesting business opportunity. And so I joined the company on January 1st and been working together with Alexander ever since.
And so I know that ClickHouse is an open source and column-oriented database engine, but I'm wondering what the primary use cases are that ClickHouse is targeting and that it enables.
Let me answer this. From the very beginning, ClickHouse was developed to power probably the second biggest web analytics platform, which has been developed in Yandex. So this is a huge Russian internet company. And Yandex has its analytical platform, Yandex Metrica, which you can think of something similar to Google Analytics. And they have a lot of users, a lot of traffic, and so on. So primary use case for ClickHouse was to power this web-based analytic platform. So its first use case was web analytics, certainly. But it happened to be a very flexible system with a lot of features and extensibility and so on. So right now, ClickHouse is used for a variety of use cases, all kinds of analytics on big data you can think of, starting from web, mobile analytics, time series data analysis. It's used in finance for stock market analysis. It's used even for blockchain analytics. There are use cases for ClickHouse in manufacturing, in medicine, in retail industry. So wherever you have a lot of data that you need to put into some database in a cost-efficient way and to run fast real-time queries, ClickHouse is a good use. And industries and different companies, they recognize it, and we see a lot of growth in the last years and months.
Oh, if I could extend that just a little bit, I think one of the things that's interesting, even though it started with this initial web analytics use case, one of the strengths of ClickHouse is that it is designed to be a general purpose data warehouse. So it is SQL based. It can do joins. It has a number of very interesting capabilities like materialized views that make it suitable for a pretty wide range of problems outside that initial use case.
And in terms of the broader market for database engines, I'm wondering if you can just characterize the position of ClickHouse and how it fits in relation to both commercial and open source databases, and just also in terms of just the broader big data ecosystem.
That's a good question. And actually, the company that I worked for before, LiveStreet, we were investigating a lot of options before we came to ClickHouse. And there are not too many. So if you go for analytical database, you don't have too many options. In commercial world, there is Vertica, Greenplum. There it is open source now, but it was commercial originally. Redshift, if you go to the cloud, Snowflake, and some bigger folks like Teradata or Oracle Exadata and so on. So Teradata and Oracle are extremely expensive. Vertica is moderately expensive, and cloud solutions have their pros and cons, certainly. In open source world, it's even situation is even worse. There is only Greenplum right now, and there were several companies who tried to make efficient open source analytical solutions, but they were not successful. One of them is Infobright, and they built quite efficient data warehouse that you can put onto your desk, so it's on the SQL Server solution, but they couldn't go for cluster. Another one was InfiniDB, which is currently a part of MariaDB. It's MariaDB column store. And there were a couple of others, but none of them was successful enough for a variety of reasons. Technology is complex to develop, it's not easy to market, and so on and so on. So Clickhouse is probably the only one who was backed up by a big company like Yandex and had a good team of engineers to execute it. So it evolved. So, and if you're talking about if you're asking about positioning, it's certainly massive parallel processing databases. So these are databases that are for analytics. They're typically column store. They're typically with architecture that scales very well to your hardware resources, GPU cores, memory, storage, or cluster, and so on.
Yeah, and I would also say that it's not just, we don't just compare ourselves to column stores. So one very common way to process data, particularly in batch, is to use Hadoop or Spark. And we see a lot of that. For example, people who are using Elastic MapReduce on Amazon, there's a huge amount of usage of that. But the big difference is that ClickHouse is real time or very close to it, whereas even with Spark, which is much faster than traditional Hadoop, you could be waiting many seconds or even minutes to get an answer to analytic questions. So there's definitely a big advantage to using this database.
And can you talk through how ClickHouse itself is architected and able to handle these scaling and performance capabilities?
Sure, I'll take that one. So, ClickHouse, as we said, is a column store. It has very similar design choices to Vertica. What does that mean specifically? So, when you load data into a table, instead of storing it as rows, the way you do in a database like MySQL, for example, what we're going to do is break up the columns and store them as arrays. Now, those arrays are stored in individual files. They're highly compressed. And so when we do a query, we will actually only read the columns that are mentioned in the query. And the decompression is very efficient. Moreover, we have optimizations that as we're traversing the array, we will, the C++, the core of the system is C++. We'll use SIMD instructions whenever possible so that instead of, for example, for summing integers, instead of just summing one of them at a time, we will push as many of them onto registers as we can, process them with SIMD instructions, and get speedups there. Second thing that we do is that we have indexes which allow us to locate. So we're selecting the columns. We use indexes which are built automatically to locate the parts of the columns that we should be reading. So we're able to drop out a lot of data there. We do have secondary index structures that allow us to be even more specific about what we read. So the amount of data that we process is then significantly reduced. Third, we're really efficient about breaking up those arrays and dispatching work onto all cores so that, for example, when you run ClickHouse on a single node, if you run a utility like htop and you have your query configured to use all resources, you will see this light up in every single core, including cores with hyperthreads. Every single core will go to 100%. And then finally, we're MPP enabled. So that means we can spread across, we can spread queries and data across multiple nodes. Moreover, ClickHouse has both built-in sharding as well as batteries included replication. So we're able to distribute the data over both shards and replicas within those shards, and the ClickHouse will automatically find appropriate parts of the data, query them, federate the results, and pass them back to you. So there's just a bunch of, there's not one thing in the architecture here. There are multiple things that are all sort of designed to work together to produce very large, very fast query results over enormous volumes of data.
Yeah, the vectorization capabilities are definitely particularly interesting for being able to parallelize and compact the overall number of operations necessary to be able to retrieve or manipulate any individual piece of data. So I'm sure that that's one of the major capabilities and then in terms of the overall sort of life cycle of data as it flows through ClickHouse, going from just inserting an individual record or a batch of records through to the storage engine, and then on the query side coming back out. I don't know if you can just talk through the overall life cycle and process flow of how that data is managed.
Yeah, this is interesting actually how ClickHouse handled that, because the data, when it's stored, in order to be queried efficiently and fast, it needs to be sorted. You can think of ClickHouse as a database with a single clustering index. So the data is stored at rest, and clustering index allows ClickHouse to locate data efficiently when this index certainly is used. But the challenge comes when the new data comes, and you need to keep the data in the same sort of structure. So what ClickHouse does is the following. With every new insert, and we typically insert not a single record, but some batch of records, hundreds of thousands or millions in one insert statement for the good performance and actually production workloads. Every insert generates a new part of the table, and it's actually called part in ClickHouse terminology. And this part is internally sorted by this primary sort order. But once you insert more and more data, you have a lot of those parts. So in query time, you would have to check all the parts for your data, load from all parts and merge it somewhere else, and then present results to the user. That would be not very good in the long term. So what ClickHouse does, it starts us to merge these parts of the data to the bigger ones. So when the new insert comes, we have new block of data. ClickHouse then picks up some old block of data, old part of data, merge it together, and produce a new part. And this process, this background process, which is called merge, it happens all the time in the background. So ClickHouse constantly merges the data, and when it merges, it's actually a merge sort operation. It's a little bit more complicated than that, because ClickHouse has to do it per single column. It has to decompress data first, then compress it afterwards. But in a nutshell, it's a merge sort, which is a very efficient operation that can be performed in a streaming fashion. And during this merge process, no query interaction is happening, so it's absolutely transparent for the user. The new merged parts of the data, they just eventually replace the old ones, and your queries are running fast all the time. So your data is always pretty much well sorted on the disk. It's not going to be a single sorted part or single sorted piece of data always, but a small number of those. And this is a very important concept of ClickHouse. Something similar exists in Vertica, but Vertica has a more complicated design with in-memory structures and on-disk structures. In ClickHouse, it always stores data in the disk, and this is the main difference. And actually, it's not a difference. You have to store on the disk if you're going for huge data. You don't have so much memory. So ClickHouse always stores on the disk. The data is always sorted, but sometimes in several parts, which are being merged in the background all the time. I think that's the main idea.
And as far as the clustering capabilities, is it a sort of master minion type of architecture, or is it an active-active where any instance can accept writes and then those writes are distributed or across the cluster for durability? I'm just wondering how that plays into the overall data flows.
It's master. It's active-active. So what you have is you have shards, and actually it's kind of interesting how ClickHouse does this, because really the shards are just defined as through a configuration file that says, hey, we have this cluster and my shards are located here, here, and here. Now, you can extend that definition to also say each of those shards should have two, three, or four replicas. In that case, what happens is you have to have Zookeeper running with Clickhouse, and then each time a part gets inserted to a particular replica, a note is made in Zookeeper that the other replicas can then refer to and recognize, hey, there's something that we need to replicate. There's a part that needs to be replicated over to our side of the fence. So the replicators, you can basically insert to any replica, and it will eventually make its way to all the other replicas. So it's kind of an eventual consistency replication model.
And another interesting feature that I noticed as I was preparing for the interview is the option for some data safeguards, such as deletion protection. And so I'm wondering if you can talk through some of those safeguards that are available and how those factor into enabling different use cases for Clickhouse that would otherwise be intractable or impractical.
It's interesting that you ask this question because normally users are not concerned of those safeguards. But yes, Clickhouse has some guards against incidental deletes of tables and partitions. Because we're talking about big data. If somebody occasionally deletes a table, it might be quite expensive and takes a long time to restore. So by default, Clickhouse doesn't allow you to drop tables or partitions above 50 gigabytes of size, but it's certainly configurable and can be disabled. Speaking of data deletes in general, it's a common feature of analytical database that they don't like deletes and updates too much. Many analytical databases, they started from write only and or insert only, and Vertica and Clickhouse are not exceptions. But currently you can delete or update data quite flexibly in Clickhouse. Probably not in a sense of traditional SQL, but in a little bit different Clickhouse way. Actually, Clickhouse has a lot of own ways to do certain types of things, which makes joining Clickhouse kind of interesting sometimes. But all those decisions have good thinking.
And I would add to that I think, as you go into analytic systems, you tend to think about deletes just in a different way. So the Clickhouse way to think about data deletion tends to be more along the lines of, hey, I've got enormous amounts of raw data coming in that I want to keep for a certain period of time, say 30 days or 7 days or something like that. But then as time goes on, I want to maintain aggregates of that data that become increasingly sparse over time. So what you would think of, the way you would think about that is you would have the raw data coming in, and Clickhouse has a feature that allows you to assign a time to live, which is based on a SQL expression. So you can, a simple thing is just keep it for 30 days, but it could also be based on some condition in the data itself. So you would do that for your raw data coming into the main fact table. And then you would build materialized views that automatically compute aggregates. Those are computed from the time that the data is inserted. And then even after the data drops out of the, gets deleted out of the main table, you would then continue to have the materialized views. So that's kind of a Clickhouse way of thinking about that deletion problem.
And then as far as getting data into Clickhouse, you can obviously insert individual records at a time, but for large volumes, that's impractical. So I'm curious what the other loading paths are for getting data into Clickhouse in a scalable and maintainable fashion.
This is a great question because the Clickhouse has such a variety of ways of loading data that it's really, I'm sure that I won't be able to remember them all, and Alexander will have to help me. So just as far as the APIs and in fact basic inserts, the principle, one really important Clickhouse principle is you don't, like many data warehouses, you don't want to insert single rows. So you want to insert in batches, say of 10,000, 20,000, 30,000, something like that. So that's the first thing. There are a couple of different ways you can do this through the APIs that I'll just mention in passing. A very common, you can insert using HTTP requests. There's also a native API format there, or we call it native TCP format, which inserts data that is already in typed and in column order. So that results in very efficient inserts. And so when we think about using APIs, you can, of course, write a Python program which invokes these. But at a first, sort of the first order approach is you actually just use the Clickhouse client, which is this command line client, and it has very efficient streaming of different data formats. So, for example, it can read CSV, it can read one line. There's a format called one line JSON. There's various other formats that it can read in. And the great thing about it is you just cat the file and basically pipe it into to Clickhouse client, and it just blasts it up to the Clickhouse server at full speed. And you can run many of these in parallel. We do that commonly for data loading. However, beyond that, there are many other ways to read data directly from the Clickhouse server. So there are these things called table functions that allow you, for example, to go out and directly read CSV off a URL. You can read data directly out of Kafka queues. In fact, Clickhouse has also what are known as table engines, which can basically take anything in the outside world and make it look like a Clickhouse table. So a common way to read from Kafka is to use the Kafka table engine, which then makes a Kafka queue look like something you can select out of. So that's another way to put it in. I think two also very, very interesting ways to load data are we can go directly to Postgres as well as to MySQL, and we can also read data directly out of those tables. So that's yet another way that you can pull data in and actually store it in Clickhouse. And then finally, sometimes you don't even need to read the data at all. So for MySQL, for example, Clickhouse uses very commonly what are called dictionaries, which are reference tables that are loaded into memory. But the base for those reference tables can be another database like MySQL. So one of the things you might do is if you have a big fact table and a bunch of smaller dimension tables, say, for example, containing product SKUs or something like that, a common way to access them is to leave them in MySQL and then just define a dictionary which will read them from the MySQL database. And every time they're referred to, Clickhouse can just pull the data in, and you'll be able to access the data directly from MySQL.
Yeah, so in a lot of ways, it looks like you're inverting the ETL model, where rather than pushing data into the database, you're actually using the database engine to pull data from other sources, which I think simplifies things in a lot of ways.
Correct. Yeah, it's a really interesting model. And I think that it also gives you some, because we talked a little bit about deletes earlier on, and one place where deletes are not being able to delete stuff easily or in the conventional SQL way can be a problem is specifically dimension tables. That's a good example of a place where you actually you may want to update things on a regular basis, and in that case, keeping them in something like MySQL turns out to be very convenient.
And when I was looking through the documentation, it seems that you can actually set up Clickhouse to be a replication target for MySQL or Postgres to simplify the change data capture approach of being able to pull data in as it's updated in the database. I'm wondering if I'm accurate in that interpretation of the documentation.
That's correct. And Alexander, you want to take that one?
Yes. So that's correct that you can do it, but right now it's not a native Clickhouse feature. So you need to install external tool or software in order to listen for replication logs or something like that on MySQL or Postgres side, and then push data into ClickHouse. But we're going to change that actually, and we envision that ClickHouse will be able to connect to MySQL or Postgres directly as a replica and listen to changes to the tables of interest. And once it's implemented, it's actually a very cool feature that we're looking forward to have it, because it allows you to speed up your MySQL or Postgres analytics very efficiently with very little effort.
And yeah, and this is a feature we love. We've had a number of conversations with people about, because if you look at MySQL or Postgres applications, it's very common to see one or two large tables, and they can sometimes, in some applications, they'll grow to hundreds of millions of rows because they might be, events from marketing campaigns or something like that. And then you'll have a bunch of little tables. There's a long tail in traditional database schemas. So what this feature would do is it would allow us to subscribe to changes on those big tables. They would be brought over and be available for processing queries. But then what we can do is, because we can integrate with the smaller tables through dictionaries and other features like that, we can go back and, as necessary, just reference the data from the small tables that's living on MySQL. So this just feels like a really compelling and interesting way of accelerating analytics on existing MySQL databases, and it's one we're definitely looking forward to getting implemented.
And one of the interesting challenges that are posed by the fact that you can pull data from these external sources or be able to subscribe to these replication feeds is the idea of schema evolution and being able to evolve the schema in ClickHouse itself when the data formats change from those external systems, or when you have maybe malformed data that's coming through, for instance, in a Kafka topic. And so I'm curious how you approach that challenge in your own experience of running ClickHouse.
I think I might, yeah, let me jump in on this because I actually worked on replication for MySQL for many years. So the short answer is that's an exercise for the reader right now in ClickHouse. This is definitely something we're looking at. The ClickHouse actually does have very flexible schema management. You can do alter column, or alter table, add columns, change data types, things like that. It does require that you have the ability to intercept the schema changes in the replication log. And certainly the MySQL replication log has this information. The trick is to see it coming and then correctly process the change. So that doesn't exist yet. And that's one of the reasons why we've actually had discussions with users about potentially replicating all data out of MySQL, but it's exactly that schema change that makes this a difficult problem. So for now, I think when people are replicating, it's better to do sort of large tables that where the schema changes are sort of few and far between, and you should be able to manage them. I think this will be improved over time, but it's just generally a very hard problem. And in particular, it is very hard to solve when you have heterogeneous replication, because there will be schema changes on the target side that are simply very difficult, or excuse me, on the source side that are simply very difficult to implement on the target. So I foresee that as always having a somewhat manual component, even in as our replication capabilities improve.
Yeah, schema evolution in general is a hard problem that doesn't appear to be fully solved in any one system. And then it just gets exacerbated when those schema evolutions are bridging different systems, as is the case when you're pulling data from these source sets into a data warehouse, or in the event of using a data lake where you have data that's landing in different schemas and then being able to manipulate and analyze across the whole historical record.
Yeah, it's just not an easy problem to solve. So I think we would be super happy if we could just get this feature in where we can at least subscribe to the ongoing data, including inserts, updates, and deletes on large tables, and then basically have a ClickHouse as it exists as an archive. I think that one's tractable to solve. And then once we've made progress on that, we'll look beyond that to what else we can do.
And so, beyond the core engine of being able to store and scale these data storage and analytics requirements, I know that there are also some interesting and advanced capabilities that are built into the engine, such as different SQL extensions and custom data types. And so, I'm wondering if you can enumerate some of the more interesting ones that are unique or particularly well implemented in ClickHouse.
Table engines in ClickHouse is probably, in general, not too interesting. ClickHouse does have a lot of different table engines, that's right. And it has table engines for its own internal structures, and it has table engines for external data as well. In particular, you can have a MySQL table inside ClickHouse, and the data will be sitting in MySQL, but you can read it from ClickHouse, like ClickHouse table. But that's probably not very interesting. The real interesting thing for me in ClickHouse is its ability to aggregate data in real time automatically using special aggregating engines with extensions of merge tree engine, which is the main core functionality of ClickHouse and which does those merge operations in the background, sorting the data all the time. So during the sorting, it also can aggregate data. So you can define that your table is actually an aggregate. So you have some sort of columns that you use as a base for your aggregation, and some other columns that you want to OLAP, calculate sums or different metrics. And Clickhouse will do it automatically in the background. This is the coolest feature Clickhouse has, to me at least, because it allows you to build very efficient systems. Consider you have a data flowing in your system at a huge rate, like millions rows per second, and it's being accumulated in a huge table. And this is a good table to look into sometimes and probably run some queries, but not on a general basis. And most of the time, you typically need a different sort of data aggregated by minute or by 10 minutes or by hour or by day. And you can build those aggregating structures, and Clickhouse would maintain aggregates automatically, and it's real time. In real time, once you insert the data is already available in those aggregates, and you can query it with sub-second response time. I don't know of any other system that has this exact feature. Another cool feature is arrays, and probably Robert will talk about that.
I will talk about arrays. I love arrays. So there's a lot of databases out there that do support arrays just as a data type. What's interesting is that ClickHouse really makes them first-class citizens in a couple of important ways. One is that ClickHouse has a feature called an array join, where you can basically compute aggregates which include a bunch of things stuck in an array. So for example, you could aggregate sales by months and you could keep an array of all the regions that contributed to that. But then what you can do is you can construct SQL queries which will flip this out so that that array goes from being sort of an array of values stuck in the row, that it basically pivots around, and you can now have a new set of rows which then associate each region with values. So the arrays give you the array capabilities give you an important pivoting capability, which is in many systems you actually have to pull data out and do the pivot yourself, for example using Python pandas. So that's one really cool thing that I love about arrays. Another thing is there are map functions that you can use to iterate across arrays and sort of change values, sum them, things like that. So you get kind of a programming model even within the SQL queries that has a lot of similarities to the sort of map reduce constructs that I think people are used to if they're using JavaScript or Python. So there's a lot of really powerful capabilities there. There's one final feature that I think is totally cool that has just arrived in ClickHouse. It's still kind of maturing. There's as of joins. And these are kind of an interesting feature. They exist in KDB, which is a very popular database for financial users. And an as of join allows you to join two tables that may, for example, contain values that have a key that is close, but not quite an exact match. So, for example, if the canonical example here is you have financial data where you have people measuring market prices, at say every 10 seconds or so, and then you have weather data, which maybe is measured, on an hourly basis. And what you'd like to do is do a join of each row of financial data to the nearest weather-related record based on time. And the as of join allows you to do that. It's a totally cool capability, and it allows you to merge data and sort of analyze data in a way that's almost impossible if you don't have it.
Yeah, I think that those sort of fuzzy joins is definitely a very interesting capability, particularly for a system that's designed for being able to work with these large quantities of data that might have some variability or some potential minor errors in generation or insertion, where you want to be able to just get an approximate value or be able to perform some estimation across these data without necessarily knowing what the exact value is, or that isn't necessarily going to match up precisely as would be the case with a typical relational system that you would use inside of an application.
Yes, that's a good point, right? And ClickHouse, in addition to those as-of joins, that I can't say they're fuzzy joins, but they have very interesting semantics. ClickHouse has some more ways to do approximate calculations. One of very useful feature is approximate unique. This is quite common when you analyze a lot of data with a visitor specific, when you are interested in a number of unique visitors. And traditionally, you have to calculate some count distinct, if you wish, in SQL. In Clickhouse, you have a different way to do that more efficiently with these approximate Unix calculations that are sampling the data using some hash functions. They're pretty accurate for the general use. And if you go to the small numbers, then they're precisely accurate. Another thing is support for sampling. So you can run queries with sampling extension, and the Clickhouse would take a small portion of the data to calculate the result, and then you just multiply it to the sample size. And this is built inside the SQL, so it's native feature of Clickhouse. Actually, speaking of Unix, one of coolest Clickhouse features here is that you can aggregate Unix. Normally, if you have Unix, you cannot aggregate Unix for one bucket of the data, for another bucket of your data, and then combine them together, because Unix just don't sum up together. Clickhouse, they found a cool way to sum up Unix, and you can build aggregates with Unix. I don't know of any other system that can do aggregates on Unix. In Clickhouse, you can do. And that makes it a great choice for companies who depend on Unix, like companies that working with some RCB networks, for example, or IP telemetry. They need to calculate some metrics or counts on number of unique devices or unique users.
And for somebody who's getting started with setting up a ClickHouse system, can you talk through the overall onboarding process and some of the considerations that they should be thinking about as far as data modeling that would be different in ClickHouse than another either relational or column-oriented system that they might be used to?
Yeah, I can take that one. This is the I think the getting started is just not very hard because you can basically install ClickHouse in about 60 seconds. If you have a decent networking connection, you just say apt install ClickHouse server and bang, it shows up. So when you're getting started, that's a typical just jump in, install from packages, just make sure you have it's nice to have good storage, but it's not a big requirement. The really interesting question is around modeling, because what I find is one of the huge differences between ClickHouse and for example, OLTP databases like MySQL, Postgres, or Oracle, is you actually don't have to think about very many things when you're starting. Yes, your data has to be in a table. We're talking SQL. But you don't have to make decisions about data types. So for example, you can start, and we actually have customers who do this. You can just take, if you have a CSV file and you want to read it and look at it and start to do initial analytics, you can just load everything as a string. The only decision you really need to make when you're loading the data is you do need to give a partition key. So that's, give some way that ClickHouse can decide how to break the data up into parts. So that's a fairly simple decision. Another thing is you do have to choose a primary sort order. So again, you make that choice early on. If you don't get it right, you can always go reload the data and try again. So that's not a problem. So first cut is, if you're really just going with new data and you have no idea what's in there, make a basic choice on the partition key, make a basic choice on the sort order, put everything in as strings. You can then optimize that as you start to look at the data. So one thing that you can do which speeds up performance enormously is begin, after you've looked at the data, go ahead and assign proper data types. So instead of a string date, make it a real date time, for example. Instead of a string integer, make it like a uint 8, so that you're just using a byte. That will vastly improve your performance. And of course, it makes your queries simpler because, when you're counting things, you don't have to apply conversion functions. And then there's a second order type of modeling that you want to do, which is to think about codecs. So codecs are going to give you their transformations that are applied to the data as they are stored, and of course as they're pulled back from storage. Sort of a good example of a codec is you may change, for example, the way that the compression works. You may, for example, on strings, we have a very powerful codec called low cardinality. And what this does is it basically, if you have, let's say you have a string value for region in some data set. Well, there's a finite number of geographic regions in most cases. Say maybe you have 500 of these. Well, if you apply this low cardinality data type, or we call it a low cardinality data type, but it's really a transformation, you apply this to the column, what it will do is automatically convert those region values to an integer and maintain a lookup table for you that it automatically then associates, so that when you do a select, you see the region name, but underneath it's just comparing and selecting using integers. So it's basically three levels. You're starting out, you can make a basic choice about the partition key and the sort order, but just have a rough estimate on the on the data types. You can then refine the data types, and then you can apply different codecs and other transformations on the data. And that's kind of the way that you can iteratively get to a really efficient schema. I think that there's also another question in modeling that comes up very commonly in many use cases, and that's what to do when you have variable schema. And that's something that Alexander has actually worked on quite a bit. And Alexander, I think that's one where you can offer some interesting comments.
Yes, thank you, Robert. In modern days, some users, they used to schema-less databases or databases with not very strict schema, like Cassandra, for example, and or sometimes serious databases like Influx or Prometheus. And they come to Clickhouse with this background. They wonder if they can do the same. And in most cases, it makes sense because, for example, consider a problem of monitoring. When you have a lot of different devices, all devices may have their own properties and so on. And it's very hard to make a schema that works for all cases. Or it would have thousands of columns per table. So instead, what we can do in Clickhouse is to store data in arrays. So you may have an array of keys and array of values, or you can have multiple arrays for different data types. It kind of gets you away from the columnar structure of Clickhouse, because array is stored all together. But you can start from this and work with schemaless data and just store everything as key value pairs. And if you decide that performance is not very good, you can then materialize some specific values or specific attributes from those key value arrays as a separate columns. It can be done afterwards. It can be done absolutely with no downtime, just by alter table, and Clickhouse will start populating those specific attributes that are important for filtering, for example, for you. And you can start querying the data using those filters much more fast and more efficiently. So this is kind of hybrid approach, right? So you start with this array or arrays and probably some other common properties like timestamps and whatever, and then you can extract certain data for the better performance. Similar to what Robert said earlier, you can start with the basic schema of these things and then continue to specific data types, codecs, and so on. And Clickhouse allows you to do everything.
Yeah, and we have users who are using exactly this approach, for example, to process logs. Keep the data in arrays and then use this materialized column feature. That's actually another really killer ClickHouse feature. The fact that you can do it with zero downtime and basically, sort of instantly begin to refer to the new column with correct type is a great feature.
Yeah, and all of these capabilities as far as the flexible modeling options puts me in mind of the current trend as far as the shift away from ETL into ELT, where you land the raw data into some source where in a lot of cases it's a data lake, but with some of these modern cloud capable data warehouses such as Snowflake DB, I know encourages you to just load the raw data into it and then do the transformation after the fact. And so it seems that ClickHouse is another case where you would just load the raw data into some source table and then take advantage of these schema evolution capabilities or schema manipulation capabilities for then being able to transform the data into a more processed form for being able to use for more advanced analytics.
Yeah, that's right. I wouldn't say that this is primarily use case for ClickHouse, but ClickHouse can do pretty well with this approach as well.
Yeah, and I think that we're definitely not. I mean, there are systems out there which will actually allow you to do. You'll have a meta store which will sort of implement schema on reads, so that you may have just text files. This is the Hadoop Hive model. That's sort of the far end of the spectrum. And ClickHouse is absolutely not designed or not intended to follow that pattern. We do require, for it to get high performance, you're really going to have to put the data into ClickHouse's storage format. We can of course refer to data in other databases, but those tend to be smaller tables. So we do expect that people are going to eventually load most of their data into ClickHouse and store it in the native merge tree format. So we're kind of closer to, in that sense, really closer to a traditional database than for example, some of the systems that are designed to read data directly off S3.
And then as far as getting ClickHouse deployed, I know that you said in terms of just the initial onboarding, you can do an apt-get install, but for actually putting it into a production context, I'm wondering what's involved and some of the edge cases that users should be aware of and some of the tuning capabilities that would be useful to point out.
Good question. So it's right that you can run ClickHouse start ClickHouse in 60 seconds, and you can run it at your laptop or high-end server. ClickHouse would run everywhere. It's absolutely portable. And when going to production, there are different considerations. So it's not always performance is actually not always the first one, and helps to ClickHouse, which is already very fast. Quite often, it's more like usability for better fit into infrastructure. Having said that, for maximum performance, ClickHouse is better optimized for running in bare metal servers because it has a lot of internal optimizations that rely to CPU cache utilization, for instance. But the data is CPU local, and sometimes if you use certain virtualizations, this is not the case. But you can go with ClickHouse to clouds as well, including public clouds like Amazon or Azure or Google Cloud. And ClickHouse works reasonably well here, given that you provided with the good storage option. It's certainly not performs as fast as on comparable bare metal servers. There is certain expense of virtualization, but it's very convenient, right? So you just deploy it to the cloud, and if everything else in the cloud, you actually don't have a reason to go somewhere else. What we see now, and in recent months, there is a growing interest to deploying ClickHouse in Kubernetes, because Kubernetes allows you to run kind of the same ClickHouse configuration everywhere. You can have Kubernetes on bare metal, you can have Kubernetes in clouds, in public and private clouds, and the running pattern for ClickHouse would be exactly the same in all Kubernetes environments. We actually see ClickHouse to be more and more popular in Kubernetes. Actually, to the moment, this is probably the only data warehouse or analytical database that can be run on Kubernetes in general at all. And there are multiple reasons for that. One of the reasons is that stateful applications and applications with storage are still pretty new to Kubernetes, and ClickHouse has also a very untrivial deployment pattern, and not just ClickHouse, but any other analytical database. So I kind of lost the thought, but it's great that ClickHouse portability allows it to run everywhere and optimize for particular use case or scenario. If you optimize for performance, you will go one way. If you optimize for convenience, you go to another way. And the trade-offs are not that huge. So Kubernetes overhead is not significant if compared to bare metal or Kubernetes running on Amazon and so on.
Yeah, I think the performance of ClickHouse on Kubernetes has been very enlightening. So the Kubernetes operator that we've developed takes what is naturally a very complex deployment, which isn't anything particular to ClickHouse. It's just that deploying data applications with state on Kubernetes involves creating a lot of resources and managing them. So the Kubernetes operator that we've developed reduces these to a single custom resource that's easy to configure, deploy, and update. But what we've definitely seen is that, well, first of all, this gives you huge flexibility because you can quickly spin up clusters. You can create clusters in less than a minute, depending on their size, of course. But we've also seen pretty promising performance results that for example, when we run tests that run on Kubernetes versus running on VMs, so Kubernetes on Amazon VMs versus just running on straight VMs, we see virtually no difference in the performance. So that's actually something that looked very promising, and we do. We are working with customers who have major deployments on Kubernetes, and we definitely see this as a growing platform for data warehouse in future.
And as far as the sort of use cases and instances of Clickhouse and customers that you've worked with, I'm wondering what have been some of the most interesting or unexpected or innovative ways that you've seen it used.
I'll give you one that just sort of blew my mind about 4 days after I got on the job. We have a customer that develops custom fraud detection systems for banks and credit card processors. So the way that they use ClickHouse is they bring it in, and the first thing they'll have to do is, in order to build the system and select appropriate models and things like that for doing fraud detection, they actually need to understand what data that financial institution has available. So they'll just ask them to give them a few CSV files containing more or less complete samples of data. They'll just throw it into ClickHouse and start playing with it and looking around. And this is exactly what I was talking about when I was discussing how straightforward modeling can be, that you can literally just start as strings. This is exactly what they do. They just throw the CSV in. They then start playing around with it. I have not ever seen a database that can do this on this scale. So it's a really interesting and innovative way to use it.
Yes, and thanks, Robert. That's a good example. And from my side, probably my favorite is some sort of distributed computation system, which one of our customer has built last year. So what they did, they set up a cluster of ClickHouse servers and developed kind of execution pipeline processing the data. It was stock market data, but absolutely in parallel in all servers. And only that pipeline, it took several steps to do very complex mathematical computations that happened to be quite efficient in ClickHouse. And after all parts of pipeline finished, the data has been merged together in a single table to be accessible by the users. You can pretty easily to develop the same thing on Spark or Hadoop, but it would take several days for results to come using given the data sizes they used. In ClickHouse, it took just several hours. It was probably 20 times performance increase. And the idea is general that you can use analytical database as computational processing engine is kind of cool, I think. But we haven't seen any other client who doing the same since that time, but probably it will change, especially given the fact that ClickHouse is getting closer to machine learning world recently. We add new features that bring some machine learning models inside ClickHouse. We investigate ways to integrate closer with some machine learning capabilities and so on. So it may change, but 1 year ago it was a real kind of wonder. And I know of some other companies who migrated their data analytics and machine learning algorithm from Spark to ClickHouse, and again, their performance difference and hardware difference was close to 1 to 20.
And another thing that I didn't ask about yet is whether ClickHouse has any concept of multi-tenancy, where you might have different groups within an organization that want to be able to leverage the capabilities of ClickHouse, but still maintain some sort of ownership of the data, and then also be able to grant either restricted access or be able to federate across different sort of groups of data within the overall platform for then being able to do higher level aggregates across those data sources.
Yeah, that's a really interesting question that actually comes up a lot, and it actually has what you're referring to is an authority model that would allow people to share data safely across tenants. And I think at this point it's fair to say that we'd have to be honest and say that Clickhouse does not have strong capabilities in this area, but there are a couple of interesting features that are coming down the pike that will make this possible. The first is to get both table and column level security. This is a standard feature that you have in existing databases, of course, like Oracle. It's also in the cloud databases like cloud data warehouses like Snowflake. This is very well developed. So this is in the roadmap and will be coming in the, hopefully sometime this year, but it remains to be seen. I think there's a second issue in multi-tenancy, though, that people sometimes overlook when they're running this. And this is that in addition to controlling access, you need to control resource usage. So this is something that will be arriving in ClickHouse a lot sooner, and that's specifically resource pools that allow you to restrict things like CPU, RAM, storage, IO, or IOPS on storage, basically control these for groups of users. And this capability is fundamental to allow different groups of users to safely use a large system. That's something that we're actually working on right now, and we expect to see that be merged into ClickHouse by the end of this year.
And as far as your overall experience of working on ClickHouse and helping customers get instances deployed and put into production, I'm wondering what you have found to be some of the most challenging aspects and some of the most interesting or unexpected or valuable lessons that you've learned in the process.
I will just focus on one place that I think is a challenge for many systems, and that is security. So we like to say ClickHouse is a young system, so it has great speed, great portability, but it's also the early use cases have involved very large quantities of data that either didn't have big security considerations. So for example, data was not considered subject to GDPR, things like that. So definitely being able to build systems that can pass PCI DSS, for example, for credit card information, or get by corporate InfoSec teams, that's definitely a challenge. And we actually just recently got our first contract to add our first security related feature. So it's for log cleansing to keep sensitive data out of logs. So we're looking forward to sort of stepping down that path. But I think in the meantime, if people are building systems, for example, that need to meet PCI DSS requirements, what they have to do with ClickHouse is think whole system and think about security groups, think about network security, and things that you can do to kind of create a trusted environment where you can safely run. So that's definitely a major design challenge for ClickHouse. I think the learning for me was that, in talking to customers, it can actually be done. So we don't actually have to have these features. There are ways to use ClickHouse that are quite secure, but it does require some additional thinking in your system design. And we hope to reduce that thinking over the next year or so.
You mentioned that ClickHouse is still a bit of a young system, and Alexander, you said that part of the reason for founding Altinity was to address some of the sort of sharp edges of ClickHouse itself. And so I'm wondering, at this point, what you see as being the shortcomings of ClickHouse and how you address them in terms of the products and services that you provide at Altinity.
That's a good question. One shortcoming Roberts just mentioned is security. So ClickHouse, it has been developed inside an enterprise without strict security requirements, and it's still lacking a lot of features that any other mature database has. So this is one of the things we're working on. Another area which is still not very good in ClickHouse is storage management. Again, it has been and probably a few hours. So, and in all cases, this is coming from the fact that ClickHouse has been developed by a single company originally with its own set of requirements and view on the product. And even 3 years in open source, they did change it somewhat, but not completely. So ClickHouse roadmap is still mostly driven by the core team, and we're working very close with the core team and community to shift the agenda and roadmap to address better the needs of the wider audience and wider scope of users. and we're working pretty hard on that actually. Probably Robert, you can add something. Yeah.
Absolutely. The tiered storage, I think, is one of the most important features. So what you typically want to do is you'll have hot data, which you may, want to dump to SSDs. You'll have older data, sort of, maybe after a week, you're content to move it to hard disks. And then after some lengthy period of time, you have data that you just don't refer to very much. Maybe you're keeping it for regulatory reasons. You'd actually like to drop that onto object storage. So I think that's probably one of the biggest things we hear from users to give people the capability to do that. We are working very closely with the Yandex core committers as well as our own team to design a solution for that and get that implemented. I think that's going to be a huge step forward. But there are many others. I think and in fact, what the shortcomings, the flip side of the shortcomings is that people want to use Clickhouse even with the things that are missing, but it's created a market demand for to round out Clickhouse, and that's actually one of the biggest things we do in our business is basically help people identify these areas that are still not mature, either work around them or actually get us budget so that we can actually fix them. And it's evolving pretty quickly. We've done a number of PRs this year, and we expect to see that double or triple. The rate at which we're adding features will double or triple by the end of this year.
And what are the cases when Clickhouse is the wrong choice and you'd be better suited by choosing either a different database engine or a different just overall system architecture?
It's not an OLTP database. So, and that's sometimes people come to it and think, okay, can I make it do both? And Clickhouse really is designed to do analytics. Well, we're not trying to compete with Postgres to like run a bank or deal with money. I think there's another case that's more subtle, which is within the analytics. If you have a lot of concurrent point queries where you're just want to get the data for like off a single row, Clickhouse is not a good solution for that. And the reason is that we're fast because we use sparse indexes. That's one of the big reasons that we don't construct these large indexes that you then have to maintain and read. But what that means is that if you ask for a single row, there's a good chance you may read 8,000 values and then decide which one you actually want. So that's a case where another database, for example, if you're, Redis might be an appropriate solution for that.
And are there any other aspects of the Clickhouse database itself or the use cases that it enables or the work that you're doing at Altinity that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think I would just summarize by saying the thing that I really like about Clickhouse is I love the speed, I love the scaling, but I think that, let's be honest, there's a bunch of databases that can do that, and that alone doesn't make you unique. What I think really creates this huge opportunity is that Clickhouse has a permissive open source license. So it's Apache 2.0. That's a really, really great feature for many people. It means it can be used very flexibly in a wide range of applications. That's thing number one. Thing number two is it's very portable. We already talked about that. It runs, bare metal to containers to clouds, and it runs well in all of those environments. And then the third is that it's relatively simple to manage. And I think this is something that is kind of inherited. We have sort of the ethos of MySQL that embedded in the design of this system. And the idea is just make stuff easy for users, make it easy to install, make it relatively easy to do the management. Don't build in enormous complexity that requires DBAs. This is a database that can be used and deployed and operated by developers. So I think that's a really powerful feature.
All right. And for anybody who wants to get in touch with either of you or follow the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I'm going to throw one out there, which is I think the biggest gap that I see globally in the industry is that we've got two separate worlds, one of analytic databases and data management, and we've also got and then we have a world running in parallel that's doing machine learning and AI. And I think the most interesting area and the place where we need new tooling and new ways of approaching things is to do things that can merge those two worlds. It's an interesting problem because it's not just a purely technical problem. There are big challenges in embedding ML, for example, in databases, But I think there's also human challenges because these problems up till now have tended to be solved or managed by different groups. So you'll have, for example, your Python data stack folks, and you'll have your DBAs or more, sort of developers who are more familiar with traditional databases. So that to me is like the big and really interesting problem that we're all kind of circling around and would love to solve.
I perfectly agree with Robert. We discussed it multiple times that there is a huge disconnect between those two worlds, and there is no evidence that is going to be fixed at some point. So there are different tries or attempts to do something that glues two worlds together, but it's not about technology. It's more like about mindset. So it will take a while to do something here.
But it's a problem we're really excited about because, well, we like math, and this is basically, it involves, understanding coming from the database world, there is a mind shift to understanding machine learning and AI. We're really excited about learning more about that, but I think also more generally excited about helping to solve this problem. It's just a really interesting problem, and there's just huge value in being able to combine these two worlds.
All right. Well, thank you both for taking the time today to join me and talk about the work that you're doing on Clickhouse and the work that you're doing at Altinity to help support that database. It's definitely an interesting piece of technology and one that I plan to take a closer look at and possibly use for my own purposes. So thank you both for all of that, and I hope you enjoy the rest of your day.
Thank you, Tobias, very much.
Thank you, Tobias. It's been great.